Welcome back, everybody, to Spring One. I'm so excited to have you here, and I'm even more excited to have our next presenter come up. Code Wars Database Designs for Application Development, and it is being brought to you by Jennifer Reef. Jennifer, take it away.
Okay, great. Thank you. So we're going to talk database decisions for application development. My name is Jennifer Reif. We do have a limited time block here, but I will be in the Q&A afterward. But if you think of something later down the road, later today, towards the end of the week, etc., please do feel free to reach out to me. I'm happy to discuss questions or technical things at any of those links that you're most comfortable, whichever medium or social platform you're most comfortable using. I'm happy to do that later on. So just a very brief background, if my slides will progress. There we go. So I'm a developer relations engineer at Neo4j. So I do a lot of different things. That means I do a lot of different things. I write code, and then I enjoy sharing what I've learned, the experiences along the way. So I do that in a variety of ways, whether that's blogging or speaking conferences and meetups. And there's a lot of different things I do both professionally and personally, and basically all of those boil down to I like learning and I'm a geek. So it kind of brings everything down to a single bullet point there at the end. So again, my contact information, that will also be on the last slide. So if you don't grab that just now, that's okay. So let's dive in. Does the database actually matter to us? And for long-term reasons, you want to choose the right technology for the job, right? You want the proper application, the right programming language, the right database. That includes the database as well. It can reduce your maintenance down the road and improvement efforts. Anything you might want to add, features, fixes, those sorts of things. Choosing the right technology can make your life easier down the road. Then there's some short-term things. So putting data into an unnatural format, basically into a data store that it doesn't really work in, first of all, isn't natural. It doesn't look natural. So it causes a lot of confusion. That can cause a lot of iterations on the data model to make it work. Well, where can we stick this? So we have to worry about normalization or data duplication, or maybe we need to size up our instance to handle something larger than what we were expecting, et cetera. And then that also causes some complex queries. So if you want to ask certain business questions, sometimes based on the data store that you choose, it actually can end up being pretty complex to write and then maintain or hand off those queries to someone else. So what we're going to find out through here is that your data storage does have impact on your application development, but maybe it's not in the way that we might think it does. And we'll kind of see that as we move through. So what we're going to do today is I'm going to take 3 different types of databases, all of which Spring Data has an integration project for. So the first one is MariaDB, which is basically an open source version of MySQL. And so relational database, typical tables, joins, and SQL queries. Then MongoDB is kind of your leader in the document database space. And so we're going to look at kind of their data model and application built with that. And then finally, we're going to look at Neo4j, which is a leader in the graph database space. So all 3 completely separate data models, completely separate query structures, and the way data is stored and all of that. And we're going to see what applications look like for each one of these. And all of that will be live coded. So I'm looking forward to that. So we're going to use the Northwind sales system. If you've done probably much database stuff, you probably have come across this. So it's kind of a standard sales system. You have products, you have orders, you're going to have customers and employees that are going to sell certain things, your suppliers, maybe product categories and things like that. We're actually going to drill into a very specific portion of this sales system. We're not going to do everything. that would be a lot longer for application development than what we have time for today. So we're really just going to focus in on your orders and your products, and then kind of the relationship there with all 3 of the different databases. So we are going to use Spring, probably makes sense since we're at Spring 1, but there's some really nice things that Spring provides that I would use whether I'm at Spring 1 or any place else. And that's, first off, Spring Initializer. So that'll give me a nice quick start, as you'll see, super important for a heavyweight demo that we're doing today. Spring Boot is going to reduce my boilerplate, so make a lot of things simpler, extract away some of the extra coding that I would have to do otherwise. And then you're going to get consistent integration with Spring Data, which we'll see how important and how powerful this actually is when we dive into the application building with 3 different databases. So Spring Data provides your annotation-based mapping for your plain old Java objects, your domain classes. It also gives you repository support via interfaces. And then finally, you get DSL or domain-specific language queries for each data store that you're dealing with. And we'll take a look more in depth on that. So the 3 projects, I have a screenshot of all of the Spring Data projects from their page over on the right-hand side. The 3 that we're going to look at are Spring Data JPA. That's going to connect to our relational MariaDB. And then Spring Data MongoDB, which, as it states, is going to connect to Mongo. And then Spring Data Neo4j, which is going to connect to Neo4j. So here are the data models. So we'll be diving in pretty heavily to the application side of things. So I just want to show you guys the data structure that we're dealing with in each one of these databases. So we have our relational there on the left-hand side, the document there in the lower right, and then graph in the upper right. And we'll take a closer look at each one of these here. So our relational model, we're going to have order table and product table. And then we have our primary key, order ID and product ID. That's that PK next to the order ID and product ID fields. And then we're going to have an order date field on the orders table and a product name on the products table, just to provide a little bit more metadata. And then when we have a crossing of orders and products, basically somebody is going to create an order that is ordering specific products, kind of your typical shopping cart app. You're going to have basically this order line item. And this is where, to have good normalized data, you often will create this associative entity or join table or lookup table, or however you like to term it, in the middle that we're going to call order products. These are basically our order line items. And we're going to have a composite key that's going to be made up of our primary key from the orders and the products table. So we have our order ID and our product key. There is the composite ID of the order products table in the center. And then we're going to have some details about our line items. So the price that they paid for that line item, the discount if they got any, and then a quantity, so the number of that item they ordered. So that's going to be our relational model. And so we can see that, and we'll dive now into the document model there on the lower right. So this one is a little bit different. So there are a couple of different ways you could model, of course, as with most databases. But I'm taking advantage of MongoDB's nesting structure, which means sub-documents. So I'm actually throwing the line items, the products that have been ordered, into part of the order document. So this is basically creating an order invoice for me. So I have an order document. Mongo has its own BSON type ID. So that's that underscore ID field. That's going to be our primary key. And then our order ID is going to be our natural or our technical key. We still have that order date field. And then in the product section, we're going to have basically the line item or invoice items, if you will. So the product ID, the product name, and then the unit price, the quantity ordered, and the discount that go along with that particular product. So slightly different, and we'll see how that can actually tweak our application as well. And then finally, we will go back and look at the graph data model here more closely. So we still have our order and our product, but basically we're kind of creating a physical join for that relationship in the middle. So this makes traversal pretty quick over relationships because you're not doing joins in memory. But you have your order and you have your product. Again, the same order ID, product ID, order date, product name fields that we've seen previously. And then on that relationship, this is basically where you have an order and a product kind of coming together is where you're going to get these line items. And so we're going to go ahead and store the quantity, the unit price, and the discount on the physical relationship in the database. So again, very kind of similar model, but it does work out a little bit differently depending on the queries that you're going to run. So with that in mind, let's dive straight into the demo. So this is the exciting part. And the one that's also the most nerve-wracking. So if I go over to my window here, I'm going to start at start.spring.io. So this is the Spring initializer. I can increase the font size a little bit better. I'm going to keep it as a Maven project. The language, I'm most comfortable with Java, so we'll stick with that. Spring Boot, the latest stable release is fine. I'm going to kind of just rename this for fun. And then we're just going to use Code Wars demo here as the artifact. I'm not going to mess with the description or package name. The packaging is fine as a jar. We're going to stick with the standard Java 11. And then we need to add some dependencies. So I'm going to start with Lombok. Some people love that, some people hate that, but it'll cut down on some of the extra code that I would have to write today. So I appreciate that, as I'm hoping you might as well here soon. So I'm adding a web dependency. This is going to let me create a REST API, REST endpoints for me to query and access the data that we're dealing with. And then I need to add in my Spring Data dependency here. So I'm going to use Spring Data JPA to start us off. That's going to connect us to MariaDB, our relational database. Now they also have a MariaDB driver dependency that I can add to connect to MariaDB. Spring Data JPA works with a lot of different types of kind of relational backends. And so in order for me to connect specifically to Maria, I'm going to go ahead and use the MariaDB driver with that. So I have all of my dependencies ready to go. I'll go ahead and generate this project, dump it into my downloads folder. That's fine. And then let me switch here and open up. Oh, come on. Open, please. Oh, let me try to re-download that. It looks like it got corrupted somehow. That's fine. Save to downloads. Let's try again. Maybe that will be better. Oops. Okay, there we go. Okay, now I'm in business. Unzip that and open this in my IDE of choice, which is going to be IntelliJ. And I'll wait a minute or two for IntelliJ to load. And then we will dive into looking at the POM when this gets all opened up. Move this into full screen too. And IntelliJ has been throwing this error at me all week. Okay. Clean that up a little bit. Okay, let's open this. Okay, so we have our Spring Boot version here and our Java 11, which we chose. Spring Data JPA, there's our dependency for Spring Data. The Spring Data Web is going to give us the REST API. There's our MariaDB driver dependency, Lombok, and then it also includes a Spring Boot starter test dependency and the Maven plugin as well. So with that, there's a couple of things that the Spring Initializer will generate for us. If you don't know already, first off, it'll kind of just bring together your skeleton for your test class. Nothing too crazy there. And then same thing basically for your main application class. It's just going to give you your main method. So nothing, again, too fancy, just the basics kind of skeleton outline there for you to work with. So with that, we're going to jump in and now we need to connect to our database. So I have 3 Docker containers running in the background, one for each database. So I have a MariaDB container, a MongoDB container, and a Neo4j container running. So in order for me to connect to each one of those today with all 3 live running, what I'm doing is I'm creating 3 different applications and they're each going to connect to a separate port so that traffic doesn't get crossed. So I've got MariaDB running against 8080. I'll have MongoDB against 8081 and Neo4j against 8082. You'll see that as we move through the applications here. Then I also need to tell it where MariaDB is going to be sitting, where to find it to connect. And it does support multi-database. So I'm going to say I want to connect to the Northwind database inside MariaDB. Then I have a username and password, good authentication. Of course, it is plain text. It's a local database, so I'm not too worried about that, but obviously not something you want to do in production. And then our driver dependency here, which will just point to say where it is. And then this is actually telling my application that I don't want to sync the application data model to the database. So this is actually the field that you will want to have in production. So it'll actually, IntelliJ will pop up and tell you disable DDL handling for your application, which you want in production. However, you can do create, update, and that will basically change your application schema to match your database or based on the database changes. Again, I don't want to do that today, so I'm just going to keep it as none. Then I've got a few things that don't quite map in my database. The way I've named things in my database tables and fields isn't quite what Spring Data JPA expects on the front end. So I have to specify a couple of naming strategies here in order for it to do the conversion well on that side. So that's what all of those properties are. And now with that, let's actually dive into our data model. So remember that we're dealing with orders and products in our Northwind system. So we're just going to start very simply with our order class. I'm going to use a couple of Lombok annotations here just to kick us off and get things kind of started with the framework. This is going to create my getters, setters equals hashcode toString, and then it's going to create a constructor with no arguments and a constructor with only required arguments. Then I want to tell Spring Data JPA that this is an entity. So this is a domain object here. And then we need to connect it. We're going to have a table on the back end that this is going to map to. Now, because again, my naming structure wasn't super efficient, I ended up, what it will try to do is look for a table named order with a capital O and singular here on the back end. And I don't have that. What I actually have is a lowercase o and plural here. So I have to actually specify this field. But if yours matches, then you don't have to do that. Okay, so with that, let's dive in. We need to specify our ID field. This is a Lombok annotation that say this field should not be null. And then private long order ID. And then we're going to have a date field that specifies order date, like that. And then do the import there. Yep, that's fine. Okay, so we'll just start very, very simply with that domain class. And then let's go create our repository interface. So order repo. And this is just going to extend the basic CRUD repository. And we have to tell it what domain class we're dealing with, which in this case is order. And then we have to tell it the data type of the ID field, which is long. In this case, order ID is a long. So we're going to return an order. We're just going to go ahead and create a single method here. So find by order ID, and we're going to pass in the order ID. That. And then let's go over and create our controller class, which is going to let us basically create a REST API that then we can and create our endpoints in order to connect to that. So REST controller, have to tell Spring this is a REST controller class, and then we can set up the request mapping, and I'm going to say anything at /orders. Remember our URL is going to be localhost 8080 because that's the application Maria is, or the port Maria is going to look for. And then anything under /orders is where this is going to go. I also want to have an all args constructor so that I don't have to separately inject my repository, as you'll see in just a second. And then order repo, and just gonna call this repo. And again, I didn't have to create my constructor because that annotation above did that for me. And then get mapping, we're going to say find by ID. We're going to create an endpoint there that we can get to this. So this is order, find by order ID. We'll pass in the order ID. Return repo dot find by order ID, pass in the order ID. And I think I have it all. I think that should give us a good start at least to run this. Hopefully, if I haven't forgotten anything. And once this starts running, we'll head on over to our browser and try to see if we can hit our endpoint and get some data back. Okay, spinning up. That's good news. No errors yet. So let's hop on over to our browser here. And I'm going to pull up a new window. Localhost port 8080 /orders, remember, and then find by ID. And we're going to pass it an order ID. And let's just look for 10414. How about that? We'll see what we get. Okay, so that's probably very difficult for you guys to see. Hopefully that helps. So we have an order ID and we have our order date, but this is nothing really complex, right? It's pretty simple. We're just looking at orders. We haven't thrown together any of our products or our line items or anything like that. You are correct. So let's go back and remedy that. So let's go over here and we're going to add in our product class. So this is the other table on the other side. And so this is going to look very similar to our order class. So data, no args constructor, required args constructor, entity, another domain entity, and it's going to have another table in Maria. And again, my naming structure wasn't Fantastic. So I have to tell it where to look for it. And then ID and non-null, product ID. And then remember, we only have one other field we're going to store here, and that's our product name. Okay, so that's our other entity. Now we need to do that center one, right? The join table in the middle, if you will. And so let's add that in. We're just going to call this ordered product. And then same thing here, data, an org constructor. We need an all org constructor here because it's a join table in the middle. And then it is its own separate entity, and there is a table for it in our database. So order products, and actually have our ID, null. I mentioned that we have a composite ID coming from the order ID and product ID from our other tables. So because we have a product ID, we actually are required to implement serializable here. You don't have to on everything, but the composite ID is one of the restrictions where you have to do that. It will give you an error if you don't do that. So we have that. And then we also had a couple of line item fields, if you recall. So we have our private integer quantity, and then we're going to have a double for unit price that they got for the item, and then any discounts they may have had. And that should do it. But we still haven't tied these entities together, right? We still have just 3 separate entities. So let's go back and do that now. So we're going to, we have for a single order, you're going to have multiple line items on that. So this is a one-to-many relationship, and it's going to be mapped by the order ID field. And then we need to have a cascade of all, and then an orphan removal of true. So basically, you don't have to do this for every table. It depends on your use case. But basically what this is saying is that if I remove an order or if I change an order, those changes need to cascade onto the associative entity table, or the ordered products table in this case. And then orphan removal means that if I completely delete an order, that means I also want to delete the related line items, because otherwise those line items don't make any sense to sit out there if there's no order tied to them. So I'm just doing that right now. And then I'm going to have a potential list of ordered products, so multiple line items that you could have on an order. And we're just going to call this ordered products. And that should handle that. Let's go over and do basically the same thing, but on the product side. So again, we're going to have a one-to-many because a particular product could be on multiple different orders. And that's going to be mapped by the product ID this round. And then same thing here, we're going to have a cascade of all and an orphan removal of true. Because again, if you remove a product, you might want to remove line items and so on. Wouldn't necessarily have to do it that way. And you want to cascade any changes you make to the product probably on down as well. And then private list again, ordered product, and we're just going to call this product orders just to be a little bit different. Now there's actually one more step we need to accomplish here, because if we go from our order class, go back here and look at it, we go over to ordered products. Remember that ordered products ties back to order and product. So it'll go back and pull those two things, and then it'll go on across to product. Well, guess what? Product ties back to ordered products. And so it'll go back and grab that. Well, that associative entity then grabs the other two. And so you get this lovely infinite recursion error. So in order to avoid that, we will add a JSON ignore properties. And then when we go over to the ordered product side, we want to ignore the order field. So I'll show this really quickly. Oh, I don't have that on here yet. I didn't add that yet. Well, let me do that really quickly. So we have a many to one. So you have multiple line items that potentially tie to an order. And the name is join column. I need a join column here. So tell it which column. And we're going to start with order ID. I got ahead of myself. Insertable false. So this is just saying, hey, I don't want to create line items without being tied to a product or an order. And I don't want to update line items, again, without being tied to one of the other two. So, and then order. Then I need to do the same thing for the product side. So join column, name, and this is going to be product ID, sortable false, datable false, and then Okay, so going back to my other class here. So when I go over to ordered product, what I want to ignore is this order field because we're coming from order, so we already have that information. And then also because we have our composite ID, this information is actually duplicated. We're coming from order, so we're already going to have the order ID. We are going to go over to product, so we're going to get the product ID. So I'm going to go ahead and ignore this composite ID as well. So we're going to add these fields, order ID, product ID. And then if we go over to our order, let's actually go on over to product here and do the same thing on this side. JSON ignore properties and add in, when we go from over to that associative entity table, we're going to ignore product. And then again, we're going to ignore that composite field because we're going to get the information when we go across the relationship itself. Now let's go over and do the center one here. So same thing happens here. We need a JSON ignore properties, but there's only going to be a single field. When we go over to order, we just want to ignore ordered products because that's what's actually going to come back to this entity here. And then same thing is going to happen on this side. We're going to have it ignore product orders, which is the field on the product side that's going to come back to this middle table. Okay, so with that, let's rerun our application. Hopefully I haven't missed anything on that. And when that starts kicking off, we will switch over to our browser and see then if we can see the relationships or these joins kind of coming together and showing us the line items. Okay, so that's looking good. So let's rerun this call. And yes, we are seeing our join come across. So we're grabbing ordered products, which is that join table in the center. And it's getting the line item information. So the quantity of the item they purchased, the unit price they got, and then any discount. And then it's going on across to the product table and grabbing the product ID and the product name. In this case, we just have 2 products here for this. Now, let's go one step further, and I want to show you how to create a custom query. So to do that, we're going to go over to our order repo, and we need to use the @query annotation. So it's going to say, I want to specify a specific type of query, and it's going to return results, specific results that I'm looking for. In this case, because I'm using MariaDB, MariaDB typically deals with SQL, we're going to use kind of a flavor of that called JPQL, which is Java Persistence Query Language. Very, very similar to SQL. It's just basically I'm going to use my application domain objects instead of table names. So we'll see that here. So select O from order O. Remember, my table name does not have a capital letter and it's plural. So I'm using my application object here to query from, and it knows what to link it to on the MariaDB side. Then I need to do a join into my ordered product table. Ordered, let's see, O.ordered products. OP, where, so that's another table, where op.product name. So going on across, basically hopping all across these joins, where the product name, like, I'm going to do a fuzzy search here. So basically this will allow me to search for some type of item, some sort of kind of product general thing, and see if there's any orders that come back that have a product similar to that. So fuzzy search. I will say the syntax on the SQL fuzzy search is a lot easier than using regex, which we're going to look at a couple of different examples of that with the next databases. So I will say that is a lot easier, even though we had quite a bit of the joins and removing fields and all that. So this is going to have multiple orders potentially, because remember, I'm doing a fuzzy search. And so if I look for something like chocolate, then I could have multiple orders come back with a variety of different products from that. So we're going to look for potentially multiple orders. So find by, let's call this product name. And we're going to send a product name as our search field. And then I need to create this on the controller side. So I need to add a new endpoint. So I'm going to say find by product for that one. And multiple orders potentially coming back, find by product name. And we're going to pass in a string product name. Turn order repo.find product name and pass in product name. Okay, So I think that is good. I can't think of anything else. So with that, let's see if we can kick this off one more time. And then we'll go over to our browser and see how that's doing. So let's change this last bit here. So find by product, and we're going to pass it a product name equals, let's just search for Choco. So anything with Choco in the name. So as we see, we're getting tea time chocolate biscuits. So the fuzzy search is working. It's ignoring the case of a capital C there. It's finding Choco in the middle of the product name itself. And then we get the order details, we get the line item information, and we also get any other products that happen to be on that order as well. And if we kind of continue on down here, there should be a Chocolade product as well. So again, Choco is at the beginning of the word, it's ignoring the case. So the fuzzy search is working well on this. And we're getting quite a few orders that are coming back. We could be even kind of a little bit more specific. Let me see if I can move my Zoom controls here. And let's search for something like coffee. So we get IPO coffee here. And again, all the details about the orders, any other products that might be on those orders. And then we can be even more specific just to be super thorough about our fuzzy search. And it is going to pull only the chocolate. It's not going to pull back our tea time chocolate biscuits because we're searching for this string itself. So it's going to find, I think, about 6-ish orders here that have chocolate on them. So with that then, let's switch, and we're actually going to go to a new database here. So we don't have too much to change on that front. If we go back to our POM, we actually are just going to highlight this and swap that for MongoDB. So literally a single word change, which is really slick. And then I'm going to reload Maven. And while that is working, I'm going to open up my application properties because we know these aren't going to work anymore. And so we're going to switch those out for MongoDB. So I mentioned different application ports for my databases. I'm going to use Mongo at 8081. Here's our connection details. MongoDB also supports multi-database, so I'm specifying a specific database to connect to. And then the authentication parameters here as well. Again, local database, so I've got my details in plain text there. So let's jump on over then. We're going to see all this lovely red text because we're not dealing with tables and JPA entities anymore. We're now dealing with documents with MongoDB. MongoDB also has kind of an unusual ID requirement. It's going to use an object ID, which is a BSON type, and that underscore ID field that I showed in the data model. So it's going to require that. One other thing is when I did the Mongo import, it did not automatically put this as a date. It put it as a string. So I need to go in and actually fix the import. I just haven't done that yet. So I just thought it was interesting that MongoDB didn't automatically import that as a date. It put it immediately to string. The other thing is, remember that we have our product line items as nested structures on our order document. So almost like a full out invoice. So in order to connect the two, I need to specify that I have a particular field here, and it's called products. And then private list of product. And we're just going to call this ordered product just to keep things kind of consistent here. That looks fine. Let's go ahead and clean up our imports here. Okay, so we're good on that front. Let's go over to our product side and do the same thing over here. So change this to a document. And then now actually, because we have nested the structure, if I created a separate document for products and did not nest these and created like a reference, I could absolutely have another ID with a BSON type and all of that. But because I nested these and didn't use references to other documents, I actually do not need an ID here at all. So I'll just remove that. And then remember that these are the line items. So I need to go ahead and add in my quantity, which another failing on the import side of things, I named this quantity ordered when I imported it. So that needs to go back and be fixed as well, but that's what we're working with for today. And then unit price and discount. So there's our line item information. We'll go ahead and clean up our imports there. this, because it's a nested structure, I actually just need an all logs constructor on this. And then our ordered product here in the center, I can select all this and comment it out because I don't need that class at all because I didn't create separate documents and kind of link across them. I've nested them. The last thing that I actually need to change is this query annotation. So if you notice, the query annotation is from a specific Spring Data JPA repository. So I need to just update that to the MongoDB version and then optimize my import. And then while you can use regular SQL with MongoDB, one thing that I thought was pretty cool is that you can actually use JSON structured queries. Ordered products dot product name in order to basically query your documents, which I think is really interesting. So with that, I'm going to pass in a regex. I'm going to give it the parameter that I'm passing in, which in this case is going to be product name. And then I can have some specific options. In this case, I'm going to ignore the case on my search string. And that, I think, should all get it. I think I remembered everything to change on this. If not, we will be tweaking as we go. So make sure that spins up. And we still have a good amount of time here, so we're doing all right. And we'll hop over here. And remember, I got to change my application to point to 8081 now. And we're going to go back to our find by ID example. And let's pass in order ID. And let's search for that same one that we did last time, the 10414. And so here's our Mongo ID object that kind of comes back. That's that BSON type. So it includes a timestamp as well as a date. And then our order ID and our date for our order. And then the line items, which is our nested products. And so you see we have our ID and our product name, as well as the line item information of quantity, unit price, and discount that they got for that item. So that's all working. Now the true test. Let's see if we can do our fuzzy search. So find by product name, or it's just product. And then we pass in the product name and let's search for Choco. So anything with chocolate. So we have our tea time chocolate biscuits. So that's working. Again, all of this looks good. We're pulling back our line item information. We're getting all the items on our invoice, all the products that they ordered. And let's see if we can kind of scroll down, and there's our chocolate as well. So that is also returning. So that fuzzy search is working, and we can be super thorough and check out our coffee, and it'll pull back IPO coffee, and we can check out our chocolate example, and it's going to pull back the 6 orders that have chocolate in them. So our fuzzy search then is working with that JSON query. It actually cuts down on quite a bit of your kind of query logic and query syntax, which is kind of nice, but it might be kind of unusual. And some of the more complicated regex, you do have to actually use some regex. So that could be confusing depending on what you're comfortable with too. So that's MongoDB. That's our document data store. Now let's switch one last time. And we're also going to do a single word change over to our Neo4j. And oh, I never did comment out my MariaDB driver dependency, but obviously it worked fine as it was. It just apparently didn't use it or ignored it. And so while that's spinning up, we're going to hop on over to our application properties. And I do have these, as you might have noticed, kind of live templated. I didn't want to have to remember all of these connection details. And so I just kind of dumped them all into templates so that I could easily pull them back out. So again, our application is going to go against 8082 now for Neo4j. This is the URI, where to look for the database. And Neo4j also supports multi-database, so I need to specify which database for it to connect to. And then, of course, my authentication username and password there to connect to my local instance that I have running on a Docker container. So let's dive on across now to our order. And one more time, we're going to change this. If you remember our data models, we have nodes and relationships that we're dealing with in Neo4j. So we can actually get rid of this BSON kind of Mongo ID, because that's no longer needed. This can go because we're not nesting our structure any longer. And then this can, this can be uncommented. I was just trying to figure out if I wanted to go ahead and uncomment that yet or not, but let's go ahead. So we'll do relationship. So this is specifying, hey, I have a physical stored relationship that I need to follow in order to get to any connections. And in Neo4j, we have specific relationship types. So kind of like you have a table name or a node label in Neo4j, relationships also have types, and that helps you kind of add metadata value to how these entities are connected to one another. So again, we don't have our ordered product uncommented yet, so we'll come back to that in just a second. Let's go on across and do the same thing for product. We need to switch this to a node. We can go back to a required artist constructor here. This needs to be an ID field, and not null. Yeah, product ID, product name. That's all good. We can get rid of these because these are now going to be on the relationship itself. So we don't have to store on the product or the order side there. Get rid of that. We'll uncomment this section again. Actually, we don't need that. You can specify the relationship going back the other direction, but for simplicity and time's sake, we're not going to cover that today. So that looks all good, I think. So finally, let's go over to our kind of middle entity here, or our relationship in this case, in Neo4j. And so we're going to remove this, and this is relationship properties. So this is saying we have an entity, a connection here, but we're basically storing properties about that entity here. So we have an ID, non-null, and we don't need to store a composite ID here. So we're actually, there really is no good business key on this entity. So what I ended up doing was just using the internal Neo4j ID. So kind of like Mongo has internal ID fields for documents. And a lot of times you'll create generated IDs for your rows in a relational table. Neo4j also does that for nodes and relationships. It'll create kind of an internal ID field. So I'm just using that here for today. But by all means, if there's a good technical key, use that instead. And then we just need to have a target node. So we're coming from order, and order is going to point to this relationship, but we need to tell the relationship where it's going to end up. So basically the node that's on the end of that relationship. In this case, it's going to be product. So we have an order that includes a product. And so that's basically what we're doing here, is we're pointing it over to the product entity. We don't need the serializable here. That can go. And I think, I also need to tell that this is a generated value. So this is something that the database will generate. My application does not control that. So I have to tell it that, and then optimize my imports. So that's all cleaned up. And I think that's in good shape. That should go away. Perfect. I still have some of these I need to clean up. Optimize the imports. And then the last thing I need to specify then is this same query annotation. So just like we had going from MariaDB to MongoDB, it's using a particular Spring Data package here. So we need to specify, hey, Neo4j has its own, even though it's the same annotation. So we can optimize our import there. And then we're not going to use SQL or this kind of JSON style querying. With Neo4j, you typically write Cypher. So that's what we're going to do here. So we have an order. We're going to go across the relationship that has a type of includes. And then we have a product on the other side of that. And then where our product name. And we're going to do kind of a regex type thing here, where we have ignore case and dot star. So any characters, ignoring that, plus our value that we're going to pass in as our search parameter. And then we're going to go ahead and do kind of an ending regex on the other side. So anything after that, basically that creates our fuzzy search. So then we're going to return all the entities that kind of come back related to that. And I think then that should put us in good shape. And then if this starts up, then we will go on over to our browser and check out our ID, find by ID endpoint, and see if that works, and then head on over to the product, and that's looking good. So yay. And we'll go over here and we'll go back to our find by ID. And okay, but we got to change our application port there. Okay, perfect. So this is coming back. So we have our order ID, our order date, and the ordered products, both Guy Toast and the Tea Time chocolate biscuits. And then we have our line item information. So the quantity they bought, the unit price they got, and then any discounts they might have had. So that looks good. Now let's go on over and do our fuzzy search and see how that's looking. Find by product, pass in the product name, and we're going to search for our Choco again. Now we've got our fuzzy search working. So we have that searching for the center of the word and our capital C. And if we scroll on down, we will see our chocolate way down here. There it is. Okay, so that's working. Our fuzzy search is working. Now, you probably noticed that, hey, it's not returning the other products on those orders. And that's because of the data model that Neo4j is dealing with. It is very specific in that we have separate relationships. So an order connects to an individual product. And that makes it really easy to select small portions of the graph that we're asking it for. And what we specified in our Cypher query is, hey, we want to return orders that have a connected product with name Choco in it. We didn't tell it to go grab the other products that are linked in that order as well. You can absolutely do that. You just need to tweak the Cypher query a little bit to add those on. But Cypher is very specific. Neo4j, because it's divided out, it's not grouping structures into documents or into whole tables. It's broken that structure apart. And so we've been very specific when we wrote our Cypher query that, hey, I only want products that have the name Choco in them, and then the related orders for those. So it's just kind of a different data model than what the other two are doing. It kind of lumped that together and went ahead and grabbed the other products on that order. So again, we can do the same thing for the coffee. We get our iPo coffee coming back. Again, no other products on those orders because our Cypher, the way we wrote the Cypher query, we didn't ask for that. And then same thing with chocolate. We're going to get those items back. And so all of that then is looking good. At least it's may not have been what we initially expected, but that is exactly how we wrote it. So with that, I think that wraps up our demo. So we're going to dive back into our slides here and kind of wrapping up and kind of a summary. So basically what we saw is that the key differences with our application was really kind of some syntax things. It's really all about your data models. So your plain old Java objects had to align with the data models. With Maria, we had an order and a product table, and we had that kind of join table in the center. With Mongo, we nested our products kind of as an order invoice type of document. And then with Neo4j, we had physical specific relationships from a single order to a single product, which kind of broke down that grouping structure. Our query annotation changed based on the database that we were dealing with. So with Maria, we wrote JPQL, but you can also use SQL. With Mongo, we used the JSON parameter syntax. You can also write SQL for that. And then with Neo4j, we used Cypher. So really what it all boils down to, the TLDR of this, is that your data model and the database that you're choosing actually impacts your application development more than how complex your business needs are, or what you try to fit into that. It's really how complex is the data model on the back end. So you want to fit your data into a database that creates your cleanest model, one that's going to be easy to modify, is simple, one that's going to give you simple queries as well, so that easier to maintain, easier to write, nothing too complex or a lot of manipulations. And then that's going to give you the best application on the other side, easy to kind of drop and change things if you need to. Notice how little we actually had to change, going from entirely different data stores. And really it's all about fitting your data into the best model there. So you can actually recreate this entire demo. I have links out there for all of my GitHub projects. So for MariaDB, I have a Docker file out there you can spin up for all of the parameters that I use to create my Docker instance for Maria, as well as the application code. MongoDB, same thing. I've got a Docker file and the application code that we covered today. And then Neo4j, the Docker file and the application code that I wrote today. And then all of the import scripts. So I've got Northwind data sets for each one of these databases. I've got instructions on how to get that loaded into your Docker file and all that good stuff. And then finally, the Spring docs, which will allow you to go into the Spring Data projects and dig into any kind of data stores or backends you might be interested in connecting to. Spring Data makes it super powerful and very easy to do so. As you just saw, we connected to 3 different ones in 55 minutes and did them all at a pretty good level. So thank you guys so much for joining, and I will hop on over to the Q&A section, but if you want to grab my contact details there in the upper right-hand corner, feel free to do so, and I hope to talk to you here in just a few minutes. Thank you very much.
Jennifer, thank you so much for that presentation. I was sitting there going, now, is she going to be able to get all those databases in 55 minutes? And I want you to know, you didn't do it in 55, you did it in 50 minutes.
Yeah, I just looked at the clock.
So I'm like, that is awesome. So that was a great presentation. And I wanted to
Thank
thank
you.
you for sharing all that with us. And I was like going, okay, this is a fantastic survey of databases. So again, thank you for coming. And
Yeah.
folks, please join her in the Zoom chat. And, have your questions ready, and even if you don't have questions, jump over and just listen to some of the other questions people may be asking, because you never, it's part of this experience is to not only learn actively by asking questions, but by listening passively to see what kind of dynamic questions people may be asking. And folks, we're looking forward to our next talk, which is Spring Security 5.5, from taxi to takeoff. And that will start right at 4:05 Eastern Standard Time. I can't wait to see y'all back.